In this video, we'll start with the second experiment of digital circuits, that is the use of NAND and NOR gates. The aim of this experiment is to study the universal NAND and NOR gates. So the reason the NAND and NOR gates are called as universal gates is because we can use a combination of these gates to create any of the other logic gates that exist out there. So we can create the NOT, the AND, the OR, and even the XOR and the XNOR gates just by using the NAND and the NOR gates. So the apparatus that we require for this experiment is the baseboard, these two ICs that are NAND and NOR, and a couple of jumper wires. So the procedure for this experiment again is very similar to the first experiment. You'll have to mount the desired IC in any one of the 10-pin sockets. Then by using the pinout diagram, you can check where the VCC and the ground pins are, and also where the input and output pins are. You'll have to connect the VCC pin to +5 volts and ground to the ground pins. You can connect the input pins either to +5 or to ground depending on the test case, and you can observe the output on the LED box or the 7-segment display. You can vary the data on the input pins, and you can verify the truth table of all the other gates that you are experimenting for. Once this is done, you can note down your observations and also what you learned from this experiment. So in the circuit diagram, it has been shown on the left hand side that there is a combination of AND gates, and on the right hand side there is a combination of NOR gates. So for the NAND gate, for the first case, if both the inputs to the NAND gate are shorted, that is if both the inputs are same, then we essentially obtain a NOT gate. And similarly for the NOR gate, if both the inputs are same, we again obtain the NOT gate. Then in the second case, if we cascade two NAND gates together, and if the input of the second NAND gate is shorted, just like this case, we obtained an AND gate. And similarly, in this case, if we have three NOR gates together, we can obtain an AND gate. And in this last case, we can combine three NAND gates together to obtain an OR gate, or we can combine two NOR gates together to obtain a NOR gate. Similarly, you can also try to construct XNOR or XOR gates using these universal gates. In the next part, we'll demonstrate how to make these connections on the mobile lab and how you can verify your outputs using the LED box.
In this video, we'll be covering the second experiment of digital electronics, that is to study the universal gates. So there are two universal gates, these are NAND and NOR. And the reason we call them universal gates is because we can use them in a variety of combinations to create other gates such as AND, NOT or OR. So in the first case, using the NAND gate, that is IC7400, we'll be creating an OR gate.
By looking into the pin diagram of a NAND gate, the pin number 14 is VCC, so it is connected to the +5 volt. Pin number 7, again it is ground. So to perform the NAND gate using NOR gate, we will require the 3 NAND gates. So this is the first NAND gate. When you see the circuit, you can see that the inputs, both the inputs are shorted and then given to the two separate NAND gates, and the output of those NAND gates is again given to the another NAND gate, which performs the OR operation. So here at first we have shorted the first NAND gate, and whose input is A, which can be given through this red wire. And the output of first NAND gate is given to the third NAND gate. Now we are shorting the second NAND gate for the second input. The second input can be given through the black wire. The output of second NAND gate is again given to the third NAND, is given as input to the third NAND gate, and the output of third NAND gate is our actual required output. So the final output must perform the OR operation. Now let us check if it is true or not. So when both the inputs are plus 1, so the expected output is plus 1. So let us check if it is true or not. So now we can see that LED is glowing. So when both the inputs were plus 1, the final output is also logic 1. When any of the input is 0, then also the output is logic 1. Now what if both the inputs are logic 0? Then let's check it. As both the inputs were logic 0, the output is coming as logic 0. So these are the operations of nothing but the OR gate. So by this we can say that we have verified the implementation of NAND gate to implement the OR gate. So we have seen the all operations. So we can say that these are the operation of nothing but the OR gate. So we can say that we have implemented the OR gate using the NAND gates.
In the second part, we'll be using two NOR gates in order to create an OR gate.
So after looking into the pin diagram again, pin number 14 is connected to plus 5 volt, and pin number 7, it is again grounded. So to implement this, we will require two NOR gate. So this is the first NOR gate which we are using. So these both black and green wire will be our inputs, and so the blue will be the output of the first NOR gate, which will be given to the input, given as an input to the second NOR gate, which is then shorted. And the output of the second NOR gate will be our final required output. So we have implemented the OR gate. So now let us verify its truth table. So the first, here both the inputs are grounded, which is logic 0. So when both the inputs are 0, we know that the output is 0. So let us check if it is, yeah. So as both the inputs were 0, we are getting, the LED is not glowing. So we can say that it is logic 0. Now what if any one of the input is logic 1? Then we can see that the output here as LED is glowing, so output is logic 1. And now what if both the inputs are logic 1? So here we can see that it is still glowing. So it means that when both the inputs are given as logic 1, the output we are getting is still logic 1. So this is the behavior of nothing but the OR gate. So we can see that we have successfully implemented the OR gate using NOR gates.